Hello and welcome to my, I believe, Sprint 6 video for Terrain Part 2. I'm going to start with my game. I didn't get things done last week, so I've gone back to last week's to do. What I'm doing right now is I am doing my light fire. In this mode, I have a low damage, rapidly firing bullet. And in this mode, I have a high-powered, long recharge projectile that you can fire like this, and it should get all the way there. We missed. But if I fire a bunch of these projectiles out, it takes a while to take down the enemy, and he's gone. When I switch into, where's the last? Oh, there's two of them. I think I can get him from here. So yeah, we have alternate fire and an alternate camera angle. So those guys are integrated, implemented, all the above. Where's that? Yep. Oh, great. Cool. So move it, and that all of the stuff that I'm doing until I get to the graphics is going to be in Azul, and the graphics will be in my own engine. So this is all done in Azul. Here, let's go to the terrain collision, or the implemented terrain. Before we jump into it, here is just a little diagram. It's not super helpful, but I have my terrain object. Has all of these things. All these are just the public methods. The scene terrain manager is a scene level multi-tin that keeps track of the current terrain. I have an iterator, which is related, is associated to the terrain object. And then I have a collision test terrain command that does the collision testing for me. Terrain object does a lot of what the terrain did last week, except without the actual collision stuff. And it's a little bit more specialized to work with the engine. I didn't open the manager for some reason. Here we go. The scene level multi-tin is pretty simple. It automatically registers and draws the terrain and then deregisters it, the current terrain. And then, just so I can prove that it happens, it is properly cleaned up by the scene. Let's find that. There it is, terrain manager. Deleted all that fun stuff. Properly cleaned up. And then in the collision test command, we have it tiered. This is my iterator, the terrain object iterator. It doesn't look like the true iterators that are packaged with STL, but it works. Here it is. I set the beginning. I have an at end, and it just iterates through the given collision area defined by the collidable. And we test all the boxes in there. So when we jump in, we should see the lovely frigate on a little slice of terrain. You'll see the group, or the default AABB, which is what these are taking. For the collision, we see the B sphere in pale blue, and is that an AABB? Yeah, AABB on the frigate. As we move, we see that as we collide with the B sphere, we turn yellow, so that's working. And then as we collide with the AABB, we turn red. So we have all of this going. I'm still working on barycentric. I haven't really got around to it yet. I'm really trying to focus on catching up on the game. Oh, and we get lag when we go off the side. Again, I'm really not worried about going off the side, because a good game designer won't allow the player to get to the edges. Here we just lose frame rate massively. Frame rate is really bad right now. So that is that. And if we were to just jump into the scene that I have running that test, all that I've done to get that terrain collision running is set collision terrain, the frigate, and then register the frigate itself for collision, and that takes care of itself. So that is the implemented terrain, and I didn't open the graphics, so let's just jump to it now. I don't want that open. This week was, while that's firing up, revamping the model, the shader, and the texture objects to be more like Azules. So if we look at the game CPP, all that I'm passing in for most of these things are the file location: model, file, texture, file, shaders. I realized since we really only have these, the way that we designed DirectX is completely different from the way that we designed, or that Azul seems to be designed. So I probably won't even have these here in the final iteration of this graphics engine. We really only need one of each, and in order to load up a new shader, we'll need to have a completely different shader object derived class. So these can go away, be stored in a manager, and just automatically be applied to their graphics object. So that's probably what I'm going to have going with these. And so the main piece of work for all of this was making the relevant DirectX entities accessible in some sort of global fashion. So what I have in the engine is I have this graphics link, which is just a singleton that is accessed and really technically owned by the graphics engine itself. So the graphics engine is responsible for terminating, or is responsible for creating the things in the graphics link, the device and the device context, and a few rasterizer states, and then also for cleaning all that up. So now that we have those, we can have a very cleaned up interface for the engine. And then I've also revamped the, let's just go down. We have this. I've revamped the models to have mesh data, not revamped, but implemented that. Everything is stored now, the center, the radius, and then the max. Pre-made models are in there. Shader objects are all updated. I was having trouble with 1 pixel textures from RGBA data. I was trying to find out ways to load those up, and then I realized, well, I'm an idiot. We already have a shader designed to do exactly that, and it's shader color. So in lieu of having a 1 pixel texture, especially with our shaders being so specialized, I'm just going to utilize shader color for that. So when we fire up this, it's probably going to have to build because I did this not here. You will see a cottage, that is the cottage, which is loaded as with multiple meshes, and you'll see the frigate, which is loaded with technically a not technically a 1 pixel texture, but it has the same effect. It's just been assigned a color and rendered that way. I believe that was it for this. Yes. Beautiful. Almost there. Here we go. So again, we see 4 different textures on a meshed model, and wrong keys. We have a very green, very olive forest green frigate, which still has the bounding sphere around it, which is, I realized it's a different orientation than Azul's bounding sphere, because this part at the top is what you use for collisions down here that you trust. It's right at the nose of the frigate, and mine is up on top. So that is all that I have for you. I will link all the documents in Perforce. Thank you and have a good morning.